Right, on this problem, you're first asked to find the eigenvalues and eigenvectors of a matrix. So I am going to send you to the eigenvector crib sheet, which is on the file folder. All you do is, let's snip this guy out so that we have it. Edit, copy, and then let's go to the Mathematica folder, the file. I already downloaded it because I went backwards, but I go to the crib sheet, how to find eigenvalues and eigenvectors. If you're not in my section, just email me and I will send this to you. So you go here where it says A, let's put that's our matrix. So I just go here, I'm lazy, so I just change my old stuff. But you have to enter the matrix. And 7. And shift enter. And then you just go down to find the eigensystem. Boom. And so I'm going to snip that out back into my WebAssign. So let's go back here and then put it here. That's what I got from Mathematica. So the first two numbers are your eigenvalues. 13 is lambda 1, 5 is lambda 2. Those go here. This 1, 1 would go here for vector 1, and you see the format. Any multiple of an eigenvector is also an eigenvector. So any answer that you put in, anything that you put in from Mathematica is correct. So if I put 1, 1 in here in the curly brackets, it would be correct. And minus 1, 3, you see this is double. These are both double those answers. That's fine. And so that's what you put in here. Easy. All right, so the next question is, one of the eigenvectors of the matrix is given. If you multiply A, which is not given, well, how do you know that what AV could be? Well, the definition of eigenvalue and eigenvector, which I didn't give you in my class because it's not quite important, and it pained me not to give it to you, but I'm giving it to you now. The definition of eigenvector and eigenvalue is that there exists a non-zero vector v such that AV is equal to lambda v, where lambda is a scalar. Lambda is called the eigenvalue, v is called the eigenvector. What does that mean? Well, it means that for 1418 to be an eigenvector, A times 1418 must be equal to some constant times 1418. So that means that all of the vectors that are multiples of 1418 could be this product. A times 1418 is a multiple of 1418. So any multiple of 1418 could be equal to this. So for example, 7, 9 could be an answer because that's a multiple of 1418 with lambda equals a half. Or 2836 could be an answer because it's double 1418. So any multiple is going to be an answer. So I'm going to have you choose through that list of vectors and find the ones that are multiples of 1418. Well, your one will be different. Now, I don't know, I didn't look at the answers, but if it were me, I would have put some vectors in there that are the wrong size too, to see if you'd choose them. But I don't get to make the problems up. Be thankful of that. They gave you another problem. Here they ask you what you're given one of the eigenvector. You're not given the eigenvector or the matrix A, but you're just told that it's an eigenvector and A times V is equal to this. So what do you know? A times V has to be lambda V. So I know that AV is equal to 2418. Lambda is an unknown, but it could be any number. So again, if 2418 is lambda V, lambda could be a half. And then if I solve for V, then it's 2 times 2418. So any multiple of 2418 is going to work just like before. So you're going to go through that list of vectors and find any multiple of 2418, just like before. So these are pretty easy. I like these kind of questions because they're testing about the definition, which I didn't give you in class, but the definition is pretty easy. The one that people usually mess up is V cannot be 0. So I would also put a vector in there that's 0, 0 to see if you choose it, because part of the definition says it can't be 0. And but again, I didn't make up the questions.